Here we're going to look at question 7 from the BMAT 2019 paper. So in this question, we're told that we have a measuring cylinder which is resting on top of an electronic balance and contains a liquid, as shown here. We can read off of our diagram that we have 375 centimetres cubed of liquid inside of our measuring cylinder, and that the total weight of the measuring cylinder plus the liquid inside is going to be 750 grams. What we then do is lower an object, X, slowly into our measuring cylinder, which pushes the liquid up to a level of 500 centimetres cubed and takes the overall mass up to 950 grams. We're told that no liquid splashes out of the measuring cylinder at any point, so we have exactly the same amount of liquid at the beginning and end. So what the question then asks us to do is to find the density of object X in grams per centimetres cubed. So if you'd like to have a go at doing this question yourself, then please just pause the video now, otherwise we'll have a go at doing it together. So to try and answer this question, I think a good starting point is usually to try and think about what equations we could use to do so. And in particular here, we can focus on the fact that we're being asked for the density of object X. So we can ask, well, what is the density? And what does density mean? Now there is an equation which you can remember for this, and that is that the density is given by the mass of an object divided by its volume. Where I've to call the density here this symbol rho. Mass is just the mass of the object m, and volume is just this capital V. So from this we can work out what we need to find the density of object X. And so what we're going to need is we're going to need the mass of object X to go on the top of the fraction, and the volume of object X to go in the bottom of the fraction. And at this point then, all we have to do is work out how we're going to find each of these. So let's first consider the mass of the object m. Now if we consider our diagram, we know that we've got exactly the same situation in both of these cases, except in this case we have object X here. So the mass has increased from 750 grams to 950 grams. Therefore, the mass of object X is going to be this difference, 950 grams take away the 750 grams, telling us that the mass of object X was just 200 grams. We can do something similar to consider the volume. So we know that in the second case, our volume is 500 centimetres cubed, and in the first case, we have 375 centimetres cubed, and if the difference is just this object X, then the volume of object X is going to be the difference between these two volumes, 500 take away 375 centimetres cubed, giving us a total volume of 125 centimetres cubed. So at this point, all we want to do is go ahead and try and find the density using these two values. So we can do this mass, 200 grams, divided by the volume of 125 grams, 225 centimetres cubed, and with a little bit of work kind of dividing through by fives, we can see this comes out to 1.6 grams per centimetres cubed. Now this answer is going to correspond to answer C given in the question.